So as we move on, we're now going to be looking at Venn diagrams and how they can be useful in grouping events together for us to go ahead and find probabilities. They're a very visual way to represent the combination of different events. So a Venn diagram is also a nice way to represent a sample space. And here we'll make a Venn diagram for the outcomes you get when you roll a dice. Here's all of the individual outcomes. And we know an event is a group of outcomes. So the event of rolling an even number is going to be all of these even numbers, and we can just ring those off together, and that is the set of even numbers as you might get when rolling a dice. The event rolling a prime number will do a similar thing. We can just circle off all of the prime numbers, and this is the set of prime numbers you might get when rolling a dice. Some things don't belong to any of those two events, don't belong to any of those two sets, and they'll just be outside of the rings, but inside of the rectangle. So when we're dealing with sets or multiple events, using a Venn diagram is actually a quite useful way to visualize what's happening. So here's a few diagrams and some terminology just for you to be aware of. The events A and B happening, or any two events happening, we refer to as the intersection of those two events. Now, A and B we'll refer to as the intersection. There are multiple intersections, but this is the principal intersection out of all of those. Event A or B is known as the union of A and B. It's not as strict as the intersection. You're allowed to be just one of the two events. You're allowed to satisfy just one of them, and you'll be included in the union. Whereas for the intersection, you have to satisfy both. So if you have a look, we'll see that the intersection is usually smaller than the union of two individual events. Next, we have the event not A. As you can see here, this is everything outside of the event A. It's the opposite of event A. We refer to this as the complement of A. And we can have multiple combinations of these, and you'll come across these in time. It's important that when looking at a Venn diagram, you can use the grammar, you can use the clues in the text to know exactly which regions we're referring to. Okay, let's try and draw a Venn diagram. In this particular question, we're working with a deck of cards. So I've mentioned before that there are 52 cards in all, 13 in each set. We've been asked to draw a Venn diagram for two sets, the aces and the diamonds. So first we're going to start with the middle. We're going to start with the intersection. Is there anything that satisfies both of these events? Well, there is one card which is both an ace and a diamond. So we can fill that in with 1. From here, we can move on to one of the other sets. What about the aces? There are 4 aces altogether. So the circle for A needs to contain a total of 4. I already have 1, so I need to fill in the rest of the 3 aces. So let's just check that the circle for A still adds up to 4, and I'm still representing my 1 ace that was also a diamond. There are 13 diamonds in total. The circle for D needs to contain 13. I already have 1, so I need to fill in the other 12 diamonds. And they will go inside circle D, but remain outside of circle A. Okay, a lot of people at this stage think they're finished with the Venn diagram, but we should always check to see whether or not there's anything or there's any outcomes that are on the outside of both of these sets. There are 52 cards in the deck. So far, I've only accounted for 16. There's another 36 cards that are neither aces nor diamonds. Okay, now that the Venn diagram's complete, we should be able to work out some probabilities. The probability of A intersection D. So the probability that I pick a card at random and is both an ace and a diamond. Well, there's only one card in that region, and out of 52, we get a probability of 1 over 52. Next, we're looking for the probability of A union D. So a card that is an ace or it's a diamond. So that ends up being anything within these circles. So 3 plus 1 plus 12 gives us 16. 16 over 52, 4 over 13. The probability that it is not an ace, the complement of A, everything outside of circle A. So I know there's 4 inside circle A. 52 minus 4 gets me 48 over 52. That cancels down to 12 over 13. The probability that I pick a card at random and it's not an ace, 12 over 13. Okay, and now let's just mix it up a bit. We've got the probability of not A intersection D, or the complement of A intersection D, a card that is not an ace and it is a diamond. That's going to be just these 12 cards, and that's 12 out of 52. Okay, so just making sure we're able to produce a Venn diagram of our own, and we can find some probabilities from there. Okay, let's have a look at an example where there's more than just 2 events that we're combining. So this question here, we have a Venn diagram that represents the animals owned by a vet's 100 clients. The key here is always to start with the intersection, the most overlapping group, usually the center of the whole Venn diagram. So this is going to be people who own dogs, cats, and fish. And from our information, we know there are 7 people who own all 3 animal types. Next, we'll go for the next layer of overlap, the people who own 2 animals. 15 people own dogs and cats. This region needs to contain 15. We already have 7 accounted for, so we need another 8. Moving on, 10 people have cats and fish. This region should contain 10. We already have 7, so we just need to include another 3. 11 people have dogs and fish. So this region here needs to contain 11. We already have 7, so we need another 4. So we've just started from the center, the overlap, where people owned 3 animals or 3 species of pet. And then we went for where people own 2 species of pet. And now we'll go for where they just own 1 species of pet. 25 people have dogs. This entire circle for D needs to contain 25. So that means there's an extra 6 that will go in this region. 53 people have cats. So this circle for C needs to contain a total of 53. So 53, subtract the values here already. That tells us we'll have 35. And we just have a few more regions to fill in now. 40 people have a fish. So 40 subtract 14. That leaves us with 26 in this region. Let's not think that we're finished with the Venn diagram just yet. Is there anybody who's on the outside of these 3? A vet's client who doesn't own any of these 3 species, but a different type of animal altogether. 100 subtract all of the values that we have, and that leaves us with 11. 11 people on the outside. Okay, so from here we should be able to find some probabilities. The probability that somebody owns a dog only is going to be this region, and there are only 6 people here. 6 out of 100 cancels down to 3 out of 50. Next, we're looking for the probability that someone chosen at random does not own fish. That's everything outside of the fish circle. That's the complement of F. And we can add those all up and we'll get 60 over 100 or 3 over 5. Now, the probability that somebody has none of these. We'd already considered this when we were making sure we had completely constructed our Venn diagram. The probability that someone is chosen at random and owns none of these animals is 11 over 100. Okay, so just be careful in making these Venn diagrams. Always start at the center and work your way out from there with the information you've been given.